Addiction is the curse of the human condition. We seem to almost be pre-programmed to latch onto anything that makes us feel good. For many, our enjoyment of certain activities are manageable, but for others, it can lead to a downward spiral. Take work for example. Many are able to leave their job at the door when it's time to clock off, but for others, one's career can become an obsession where all they do and think of is their occupation. The daily cup of coffee may seem harmless, but the headaches and grumpy demeanour would beg to differ when you don't get your caffeine fix. Because we as a species are so susceptible to addiction, scientists have sought out to find out why. One such study towards the end of a very drug-influenced 1960s would seek out to find out why we seem to fall so hard when it comes to substance abuse. After all, we are faced very regularly with the risks of drug use and addiction, and yet so many don't heed the warnings. The experiment, rather than studying human addiction, would focus on the animal kingdom, and would make use of a bizarre contraption that allowed monkeys to self-administer highly addictive substances such as cocaine, amphetamines and opiates. The experiment would result in terror for its subjects, where overdose, bodily disfigurement and mental anguish were just some of the outcomes. But the results would only end up proving the obvious, that addictive drugs are addictive. And as such, the study would go down in infamy for its unethical use of its test subjects. My name is John, and today we're looking at the 1969 self-administration of psychoactive substances by monkey study, better known as the 1969 monkey drug trials. You're watching The Dark Side of Science. It is the 16th of June 1969, and three scientists release a controversial research paper. The trio have set out to delve into the darkest depths of addiction, but study rather proudly showcases a device that allows their animal test subject to self-administer drugs intravenously. But our story starts many years before the controversial study with the budding career of Maurice Seevers. Maurice Seevers was studying for his doctorate in pharmacology in 1928 under the tutelage of Arthur Laurie Tatum at the University of Chicago. During his time there, his interest was sparked in the study of addiction and its psychological and physiological impact. His professor moved to the University of Wisconsin in late 1928, and Seevers would follow 2 years later after completing his PhD and MD. During his time with Tatum, the two studied opiates, cocaine, and novel barbiturate sedatives. During the late 1920s, Seevers would release several papers supporting a new theory of opiate addiction. His experiments to support his theory involved testing on dogs, cats, and monkeys to explore the phenomenon of psychological tolerance and how it is linked with physical dependence. This theory was coined as dual action theory. Knowing that human addiction is linked to the high of the drug and the aversion from withdrawal, Seevers took on the suggestion from Harry Harlow that addiction in animals is a delayed condition response, where animals learn to associate the administering of the drug with positive sensations. Seevers combined Harlow's suggestion with his own theory of addiction, as euphoria from the drug combined with relief from withdrawal. In order to create addicts in his experiments, Seevers employed a 7-day dosage schedule, with only a large enough dose to create a small reaction from the subject. The dose was incrementally increased, and it was found that after a month, noticeable behaviours were exhibited by the subjects, such as excitement when it was injection time. The subjects would even show subdominant body languages towards the administrator. During this period, of the 1930s, Seevers developed a scale to quantify the effects of withdrawal in his subjects, which by now included dogs, rats and monkeys. This included noting certain behavioural traits, such as clutching at the stomach and chasing the hand holding the hypodermic needle before administration. During the 1930s, the National Research Council set out to try and find a non-addictive morphine derivative, which pushed Seevers' studies into the forefront and also helped out with funding. But as the 1930s drew to an end, and the decade gave way to the 1940s, this search would be put on the back burner due to the Second World War, and as such, this affected Seevers. During the 1950s, Seevers' research was becoming less relevant, and as such, he sought out to revamp his experiments to try and simulate the more behaviour-driven model of addiction. Instead of a regimented single daily dose model, Seevers set out to mimic a more human form of dosage, for example, multiple doses in one day. He would also further modify his experiments to allow the animals to self-administer, and that leads us onto the infamous monkey drug trial. Seevers teamed up with another two scientists, Gerald Deneau and Tomojo Yanagita, and planned the experiment to take place at Michigan University. The substances to be explored were morphine, codeine, cocaine, amphetamine, pentobarbital, ethanol and caffeine. The experiment set out to explore drug addiction of non-physiological substances, i.e. drugs that don't give you a physical withdrawal but can cause psychological addiction. At the time, being able to model this type of addiction was difficult when working under Seevers' dual action theory of euphoria of the drug and fear of the pain of withdrawal. As drugs such as cocaine don't create a physiological addiction, but are very reinforcing in humans, leading to a psychological dependence. In order to test this, a method of self-administration was needed, and this had already been tested on rats in 1962 by a scientist called Weeks. Weeks had pioneered a method of conditioning rats to self-administer morphine with the use of a lever which delivered a dose intravenously to the animal. Interestingly, the animal would continue to self-administer the drug, maintaining a dependent state, similar to the way in which a human addict would do so. Another study in 1964 by Thompson and Schuster also employed intravenously delivered morphine, but in monkeys that had been restrained. This study set out to see the reinforcing capabilities of morphine versus food, but they didn't look to see if they could produce an addict from just a spontaneous lever pull. For Seevers' new study, this method would be used as a basis for a drug delivery in monkeys, but with a wider variety of drugs. Crucially, the new experiment would try and find if after the first injection of any drug by spontaneous lever press, would the participants continue to seek reinforcement by increasing the number of lever presses and maintain a pattern of self-administration over longer periods of time. Thus, if a continued behavioural pattern of self-administration was observed, then a psychological dependency could be demonstrated. Each monkey was housed in a small cubicle, 36 inches high, 30 inches wide and 26 inches deep. The floor had a mesh screen with a pan underneath that facilitated ease of cleaning, with it being flushed every 4 hours. There is also a panel with 2 switches mounted on the back wall of the cubicle. These were key to testing the animal's drug dependence. The first, when activated, administered a dose of the drug to the animal. The second made all the same sounds as the dose, but just re-delivered the drug back into the reservoir. This was to see if the monkey was seeking the drug or just playing with the switch. Both switches would be swapped around at random intervals. There was also a drinking fountain next to the switches for water, and thus most of the monkey's basic needs were met. The infusion machine could also be programmed to deliver a dose, as well as a manually controlled on top of the operant control from the switch. The monkeys were intravenously connected to the drug infusion unit via a catheter, which terminated at the right atrium of the animal's heart. To hold the animal and catheter together, the monkeys were attached to a metal harness, which itself was attached to a restraining arm which allowed movement around the cubicle. 25 seconds was required to administer the drug, and another 25 seconds was needed to refill the syringe. This helped restrict the number of doses. The machine could administer a dose in 4 different ways: 1 by monkey alone, 2 by automatic timer, 3 by the timer if the monkey fails to press the lever within a predetermined time, and 4 by the monkey, with a timer blocking the circuit after injection, preventing the monkey from taking the next injection until predetermined time had elapsed. Each monkey was taken from a pre-established breeding colony at the university. The experimenters aimed for weights of subjects to be around 3.5 to 4 kilograms. The subject is placed in the harness and restraining arm, and on average an acclimation period of around 2 to 4 days was required for each monkey to get used to their new situation. Then the catheter was to be surgically implanted into the jugular vein under barbiturate anaesthesia. Post-surgery saline solution was injected into the catheter every 3 to 6 hours until the wound had healed. This roughly took 5 days, after which the subject was ready for experimentation. After fully recovered, the monkey is introduced to the switches in its cubicle. At this point, the active switch, that is the switch that can administer through the catheter, is only able to give a dose of saline solution. A signal light is placed above the switch to give a visual indication to the monkey that pressing the switch will result in a dose. For the next few days, a baseline is recorded of the amount of times the subject presses the switch for the saline dose. After the control period, the test drug was introduced for the first time. It was found that most subjects would either keep on pressing the switch for saline or after a few days lose the novelty interest. In the case of the former, the introduction of the test drug was pretty easy, as the monkey would self-dose as it had done with the saline. However, the latter would require a little more incentive. This was a raisin taped to the switch. After the first dose of drug was received positively, then only 2 to 3 raisin incentives were needed to condition the subject to the lever pull equals drug mechanism. As multiple monkeys were being employed for looking at various different drugs, understandably, not all responses to the drugs were positive. This is where the automatic dose function of the dose machine comes into play. If the monkey didn't take to the test drug initially, a potential dependence could be made by timed intervals of the drug administration. If the animal began to have a positive preference for the drug, then an increase in self-administration would be seen. However, if after 1 month the monkey still didn't show a preference for the drug, then it would be deemed that the animal hadn't developed a psychological dependence. Now the experiment was really multiple individual experiments with its own group of monkeys for each substance, and as such, the length of the study varied by drug. I'll go through each one in a different order to the 1969 research paper, and instead of order of outcome for the participants, best to worst. Naloxone. This study lasted a month, as none of the participants initiated self-administration, and after automatic doses ended, withdrawal only lasted around 2 days. Caffeine. 2 of the 4 monkeys failed to initiate self-administration of caffeine. 1 initiated and 1 failed to initiate self-administration, although priming with automatic injections caused the latter to begin self-administration. The pattern of self-administration of caffeine was in all cases sporadic and irregular, resulting in no deaths or noticeable withdrawal effects. Morphine. This experiment lasted a long time and was the substance the experimental team had the most experience with. 11 monkeys were used and 3 failed to self-administer, but after a little encouragement, all became drug dependent. During mechanical failures, the monkeys showed withdrawal symptoms and were observed rapidly pushing the lever, frantically trying to get another hit. This part of the study lasted 16 months, and apart from being morphine addicts and being dopey compared to their control counterparts, the general health of the participants was good. It was seen that for the first 7 to 8 weeks, the participants increased their dose, eventually evening out, although one increased the dosage for 30 weeks. No one died during this substance study. Amphetamines. All 5 of the monkeys initiated self-administration, and not long showed signs of hallucinations, plucking the fur off their arms, but none died. However, by the end of the study period, the participants were noticeably distressed. Cocaine. 4 monkeys were used to study the effects of cocaine. Initially, only half began to self-administer. They found that after 30 days, one of the monkeys had died of an overdose. In order to increase the length of the study, limits to amounts of cocaine was implemented. After the 30-day period, the monkeys began withdrawn, stopped eating and showed signs of hallucinations. Some bit off their fingers and scratched off their skin. They pressed both levers and were noticeably confused. Ethanol. 4 of the 5 monkeys in this experiment initiated self-administration, but for the first few months self-administration was interrupted by days of voluntary abstinence. These gaps would reduce as time went on, and the reactions from the animals was similar to what would be expected in a drunk human: drowsiness, lack of spatial awareness and tiredness. When withdrawal was tested, the animals became sick, experienced tremors and even showed signs of hallucinations. 2 would die, but not from overdose, instead asphyxiation during their sleep from respiratory obstruction. Codeine. This involved 5 monkeys and only lasted for 8 weeks. 4 started self-administration, with only 1 needing to be initiated by the use of the automatic doses. The dose rate increased as each subject continued to self-administer, but after 6 weeks the first monkey died due to convulsions because of overdose, and by week 8 all of the others were dead, also from severe convulsions. Now the experiment highlighted some interesting results, because previous experiments had made use of psychologically dependent animals, i.e. they had been exposed to the substance via operant conditioning. The 1969 study, however, by using non-psychologically dependent animals who were naive to the effects of the drugs, showed that addiction in this case was chosen by the subjects to keep themselves under the influence, much like how humans can continue their dependency even after the face of negative ramifications such as familial, social and monetary problems stemming from their addiction, although a course of withdrawal also acts as punishment for not continuing to take the drug. What they also found was that not all monkeys began self-administration and needed the automatic doses to become hooked. This shows that some are more predetermined for addiction than others, much like in humans. By making use of cocaine and amphetamine in the study, it was shown that addiction is more likely caused by a psychological rather than physiological means, as both these substances don't create a physical dependence. Now these results are very interesting and help provide a greater illumination of drug addiction, but it was controversial, not in its results, but in its method. The experiment isn't cited in multiple most unethical studies lists for a reason. Now I did mention Harry Harlow earlier in the video, and the criticism of this study and Harlow's work follow pretty much the same lines. That is the unethical use of animals, where they essentially were tortured and killed during the experiment through the creation of long-term drug exposure. Although the experiment hasn't had as much exposure as say the Pit of Despair and the Monkey Mother, the trauma inflicted on the animals is no lesser an affair. Seevers' career wouldn't be negatively affected by the study, and he would continue to use a similar setup to explore the link between nicotine and addiction. The study has become one of the keystone cases in anti-animal testing movements, as the experiment seemingly ignores the Helsinki Declaration, where the welfare of animals used for research must be respected. This is especially saddening as the results were essentially, in its most simple term, drugs known to be addictive are actually addictive. I'm going to rate this subject around a 4 on my ethical scale. Do you agree? Let me know in the comments.